A very good morning, friends. Myself S.S. Jugade, and today we are going to discuss the new technology, that is MEMS. Okay. So what is the MEMS technology? MEMS, that is micro electromechanical system. This is the future of technology, but today's choice. So what is the MEMS? So micro electromechanical system, or MEMS, is a technology that in its most general form can be defined as miniaturized electromechanical elements, that is mechanical system, that is micro electromechanical system, that are made using techniques of microfabrication. The critical physical dimensions of MEMS device can vary from well below 1 micron on the lower end of the dimensional spectrum all the way to several millimeters. Likewise, the types of MEMS device can vary from relatively simple structure having no moving elements to extremely complex electromechanical system with multiple moving elements under the control of integrated microelectronics. The one main criteria of MEMS is that there are at least some elements having some sort of mechanical functionality, whether or not these elements can move. The term used to define MEMS varies in different parts of the world. In the United States, they are predominantly called as a MEMS, while in some other parts of the world they are called as a microsystem technology or micro machined devices. While the functional elements of MEMS are miniaturized structure, sensors, actuators, and microelectronics, the most notable elements are the microsensors and microactuators. Microsensors and microactuators are approximately categorized as transducers, which are defined as devices that convert energy from one to another. In the case of microsensors, the devices typically converts a measured mechanical signal into a electrical signal. So the term used to define the MEMS varies in different parts of the world, as I already told. So while the functional elements of MEMS have different applications and wide variety of range, MEMS and nanotechnology applications are also having a wide range. As you see, MEMS is a combine of mechanical and electrical system or electronics. So microelectrical system is a technique of combining electrical and mechanical components together on a chip to produce a system of miniature dimensions. So integration of number of micro components on a single chip, which allows the microsystem to both sense and control the environment. So generally these are the components made up of between 1 to 100 micrometers in a size. Devices generally range in the size from 20 micrometers to a millimeters. So look at this. MEMS is the combination of electronics, microstructures, microsensors, and microactuators. These four are combined together to form a MEMS, that is micro electromechanical system. So if we compare these MEMS with integrated circuits, that is ICs, then what we find? This is the comparison of ICs and MEMS. So MEMS having a 3D complex structure but IC is having a only 2D structure. MEMS doesn't have any basic building blocks, but in case of ICs, transistor is a basic building block. MEMS may have a moving parts, but ICs does not have any type of moving parts. MEMS may have a interface with the external media, but ICs are totally isolated with the media. This is the main difference. So functions include in MEMS the function includes like biological and chemical and optical etc. But in ICs only work for electrical field. So packaging of MEMS are very complex and difficult, but packaging techniques are well developed in case of ICs. So it is easy to pack. So what are the sensors used in MEMS? Sensors are the prime important devices in case of MEMS. There are different types of sensor, as you know. Then what is meant by sensor? First of all, a sensor is a device used to measure a physical quantity such as temperature and convert it into the electronic signal or some kind like voltage without modifying the environment. So converting the physical quantity into electrical quantity, what we call as a sensor. So sensor, what can be sensed by sensor? Almost everything can be sensed by sensor. So commonly sensing parameters in case of sensors are pressure, temperature, flow rate, radiation, chemicals, pathogens, etc. So sensors is having a different types like 2-axis magnetic sensor, 2-axis accelerometer, light intensity sensor, humidity sensor, pressure sensor and temperature sensor. These are the all sensor which can be used in MEMS. But why MEMS for sensors? Because it is having a very smaller in size, having a lower power consumption, having more sensitive to input variations, cheaper due to the mass production and less invoice than the larger devices. Due to these advantages, MEMS are used for sensors. Application. MEMS have a number of applications. Look at this. In case of medicine, there are numerous possible applications for MEMS technology as a breakthrough technology, along with the unparalleled synergy between previously unrelated fields such as biology and microelectronics. Many new MEMS and technology applications will emerge, expanding beyond that which is currently identified or known. Here are a few applications of current interest, like number 1, medicine. So there are a wide variety of applications for MEMS in medicine. The first by far that most successful application of MEMS in medicine are MEMS pressure sensors, which have been in use for several decades. The market for these pressure sensors is extremely diverse and highly fragmented, with a few high volume markets and many lower volume ones. Some of the applications of the medicine can be the largest market of MEMS pressure sensor in a medical sector is the disposable sensor used to monitor the blood pressure in our hotlines or patients in the intensive care. These devices were first introduced in the early of 1980s. They replaced other technology that cost over $500 and which had a substantial recurring cost since they had to be stabilized and recalibrated after each use. MEMS disposal pressure sensors are delivered pre-calibrated in a sterilized package from the factory, cost near about only $10. MEMS pressure sensors are also used to measure the pressure during birth. The device is housed in a catheter that is placed between the baby's head and the urine wall during the delivery, and baby's blood pressure is monitored for problems during the delivery. So MEMS pressure sensors are used in hospitals, ambulance, monitor the patient's vital signs, specific patient blood pressure, etc. So in case of medicine, it is a wide range of application. It is the MEMS pressure sensor is also used in respiratory monitoring, because the respiratory monitoring used as a ventilators to monitor the patient's breathing. So MEMS pressure sensor used in respiratory monitoring also. MEMS pressure sensor are used for eye surgery to measure the control the vacuum level used to remove the fluid from the eye, which is cleaned of debris and replaced back into the eye during surgery. Second is biomass, or what we call as biomems, or what we call as biotechnology. Biomems are used to refer to the science and technology of operating the micro scale for biological and biomedical applications. MEMS and nanotechnology is enabling new discoveries in the science and engineering, such as the polymers chain reactions, microsystem for DNA applications and identifications, enzyme linked immunity system, or capillary electrolysis, electroportions, or micro machined scanning tunnel microscopes, etc. So biomems have a wide variety of applications. In case of microphones, these MEMS microphones are also called as the microphone chip, which is widely used in the present day of communication world. In case of military, micro electromechanical system technology helps projectiles to reach the targets accurately. So what are the advantages and disadvantages of these MEMS? It minimizes the energy and materials. It improved advantages are it minimizes the energy and materials. It improves the reproducibility. It improves the accuracy and reliability. It increases the selectivity and sensitivity. In case of disadvantages, a farm establishment requires a huge investment. Micro components are costly compared to the macro components. So design includes very much complex procedure. Look at this. This is the examples of design for manufacturability, fabrication database, theme. These are the different examples. So what is the fabrication process? How MEMS are fabricated? MEMS are fabricated by one, deposition, second patterning, and third is etching. In case of deposition, they use the technique of physical vapor deposition and chemical vapor deposition. In case of patterning, they use the lithography. It includes the photolithography, electron beam lithography, ion beam lithography, ion track lithography, or X-ray lithography. In case of etching, they go for the wet etching and dry etching. So these are the fabrication techniques used in the MEMS. MEMS deposition technology can be classified into the already discussed chemical reaction, that is chemical vapor deposition, electrodeposition, epoxy, and thermal oxidation. Deposition that happens because of physical reaction are physical vapor deposition and casting. So you can see here patterning, or what we call as lithography. These are the radiation, these are the mask having a central hole. This is a photosensitive material and this is a substrate. So photosensitive material material's properties changes only where exposed to the radiation. Spray substrate with the developer solution. Look at this. A positive resist developer solution removes exposed material. This is the exposed material. Here negative resist developer solution removes the unexposed. These are the unexposed surface. Here removes the unexposed. Or positive resist developer solution removes the exposed area. So you can see clearly the difference of etching. Etching is the process of using strong acid to cut the unprotected parts of the metal surface to create a design in it. There are two types of etching process, wet etching and dry etching. You can clearly see the difference between wet etching and dry etching. So challenges in front of microelectromechanical system. Design and packaging. The design, as I already said, design is very complicated because its overall entire size is near about micrometers, near about 50 to, some of the parts are 50 to 100 microns having in size. So its design is yet complicated. Testing is another challenge. Sensing, latching, controllability and reliability, these are the remaining challenges in front of MEMS. So conclusion, MEMS promises to be an effective technique of producing the sensor of high quality at lower cost. Thus we can conclude that MEMS can create a proactive computing world. Connected computing nodes automatically acquire and act on real-time data about the physical environment, helping to improve the lives, promoting a better understanding of the world and enabling people to become more productive. So if you have any doubt, then let me know. Thank you.